All right, so let's do this one here. Oh, my bad, Angel, sorry. The first question says, determine all the intervals on which f prime of x is decreasing. So this is kind of getting to what Georgie was saying. All right, we just spent that whole last link looking at the graph of the derivative to make conclusions about the original f of x function, right? So if I want to make a statement about my first derivative function where it's decreasing, where do I need to look? The second derivative. I need to go to the second derivative. So look what they gave us. So they gave us the first derivative. So before I do any of this, I'm going to find the second derivative. Yes? It all depends on what they're asking you to make a statement about, Gael. If they're asking you to make a statement about the first derivative, you need to go the next one. So in this case, the second. If they were asking us to make a decision or a description of the original function, I've already got the first derivative. I wouldn't have to do any derivatives. You'll see. We're going to do a couple. I think your brain will start to sort that out. Okay, so what's the derivative of x to the fifth power? Excellent. And then what's the derivative of 15x to the fourth power? 60x cubed. All right, this is the second derivative. I want to find critical points here to see where we're going to end up changing signs. All right, so critical points mean wherever this equals 0 or wherever it's undefined. Guys, this is a polynomial, so polynomials are defined everywhere. So I just need to set it equal to 0. All right, so to solve this, I'm going to do some factoring. What can I factor out of these two terms? 5x cubed is right. What's remaining when I factor those out? X plus, I heard 14. Is that right? I don't think it's 14. Is it 12? Is 12? Yeah. 12 times 4 is 48, plus 12 is 60. All right. So now we're going to set these equal to 0. Equal to 0. So this one's 0. I just want to see the reaction. All right. What makes this one 0? Negative 12. All right. I'm going to draw the number line. All right. I don't think I did a very good job of this on Tuesday, so I'm going to try to do a better job right now. When I draw my number line, I want you to think that these are all x values. So I don't think I explicitly stated that. So these are all x values. All right. Here's negative 12. Here's 0. But I also want your brain to think that if I move all the way to the left, I would be approaching negative infinity. If I move all the way to the right, I would be approaching positive infinity. Everybody okay with that? All right. Now you guys know that at this point I'm going to choose my TPs. Right? These are my test points. Make sure when you're doing this on the AP exam, right? Because this will be lots of multiple choice questions. Line up your TPs. Here's what I mean by that. Okay? What test point am I going to use that's to the left of negative 12? Negative 13. So write negative 13 in that interval. Do you see how I wrote that negative 13 between these two? Okay. What test point? You've got options here. What test point do you think I'm going to choose in between 0 and negative 12? I'm going to choose negative 1. I know you're thinking, but isn't negative 1 closer to 0? Yes, but I want my brain to know that whatever I get here with this sign is talking about what's happening in this interval between negative 12 and 0. So that's why I put it in the middle. Everybody okay? And then what am I using to the right of 0? 1. Is everybody good on that? I just want to make sure as you do these that you're really, really focused on where you're writing them. Okay? Then the thing I care about is the sign of, and this is not the first derivative anymore, right? This is the derivative of the first derivative. So I'm going to write the sign of the second derivative. Okay? Everybody ready? Okay, here we go. I'm going to do negative 13 first. What's negative 13 plus 12? I don't care about the number. They're opposites, right? So you subtract them. So the key thing is it's negative, right? Everybody go on that? It's negative. What's a negative cubed? Still a negative. What's a negative times a negative? Positive. So this sign is positive. That's for negative 13 test point. Yes. Let's do negative 1. What's negative 1 plus 12? Positive. A negative 1 cubed is a negative, right? A negative times a negative times a negative would be still a negative. So what's a positive times a negative? Negative. Okay, now I caution you guys on Tuesday to just assume we're going to follow this pattern, right? I hope you saw on a few practice problems. It doesn't always just like alternate. So we got to do the last one. Let's do 1. 1 plus 12. 1 cubed. Positive. So positive times a positive is a positive. Okay, now the question is asking for where is our derivative decreasing? Okay, so if we're looking where the derivative is decreasing, I'm looking at where the second derivative is negative. So where is my second derivative negative? So just kind of work your way up. Very good. That's exactly right, Jimena. Negative 12 to 0 is the answer. That's it. So let me write that out, actually. F. Absolutely it is. The only thing that's a little bit different is we didn't have any second derivatives on Tuesday. Question, Guy, go ahead.
Say that question is asking where it's increasing. We would put negative 12 to the negative infinity.
Other way around, left to right.
Negative infinity to negative 12.
Then the U. Exactly right. Great question. If it asks where the first derivative is increasing. Totally, yeah, you're good. Everyone okay? All right. I'm going to skip number 2. The reason I want to skip number 2 is it's because it's literally the question that Gael just asked. He essentially just asked, what if it said increasing? Right? I know it's a different problem, but it's saying, here's the first derivative. Talk about where the first derivative is increasing. So we would have to do what? Find the second derivative to then find the critical points and then use those critical points to make our intervals, test points, all this stuff. It's the same process. Everyone okay if I skip that? Because the next 2 are not the exact same. Okay, go to 3. So flip in your paper number 3. All right. Hopefully your brain will start to see, because Gael, I think you were starting to ask this question. Hopefully you'll see how this is a little different. Georgie, I think you asked something yesterday or the day before about this as well. Okay, what function did they give us? The derivative of f of x, okay? And we want to make a statement about what? The original. So if we want to make a statement about the original, I'm going to be doing all my work with the derivative, which is this one right here. So do I need to take a derivative? They already did it for me. So my first step is just to write the derivative and figure out where is this function equal to 0. You know, off to the side I would say or undefined, but all of these are polynomials, so they're defined everywhere. So let's factor. What can I factor? Oh, I missed an x, my bad. What can I factor out of these 3 terms? I can't factor out a number, right? Because I am going to factor out technically a number, because I'm going to factor out a negative as well, right? Do you see how the first term is negative? I want to get that out of there. So I'm going to factor out a negative x. And what is remaining? X squared plus 6x minus 72. All right. Can you guys think of factors of negative 72 that add to positive 6? No. Not 18, no. Not 19.
8 and...
It's not 8. Yes, I thought 9 and 8 first, but no. Somebody said it. It's 12 and 6, right? Because 12 times 6 is 72. And so I need this to be a positive 12 and a negative 6. I promise not all the questions will have a critical point of negative 12, even though the first 2 have. Okay? Now, do I care about what I pulled out of the beginning of this, the negative x? Do I care about this? Yes. Why do I care? Because it has an x. So don't forget, a lot of kids will forget that 0 is one of your critical points if you pull out a variable. So be careful there. X equals negative 12. X equals 6. Okay, so here's my number line. So I've got negative 12, 0, and 6. I'll put in my negative infinity and my infinity. Let's get Miss Aguilera is out of town, so it might be a little loud. All right, for the next few days. Okay. What test point am I going to use for this first interval between negative infinity and negative 12? Negative 13. We just used that one, right? Okay. What's between negative 12 and 0 that I'm going to use? Negative 1. On the other side? 1. Don't forget, because we have another critical point, we have another test point here. I'm going to use 7. Again, could you use 10? Absolutely. Okay. And this is the sine of... Actually, this is the sine of the first derivative. It's okay. No one's upset. Okay, ready? So I'm doing negative 13 first. So negative 13 plus 12 is a negative. Negative 13 minus 6 is a negative. Negative times a negative is a positive. But be careful here. What's the opposite of negative 13? Positive. So that's a positive times a positive, which is a positive. So see how the first part says the opposite of x? So when I plug in negative 13, it would be the opposite of negative 13, which would be positive 13.
It's the same as negative 1 times negative 13.
Yes, it's the same as negative 1 times negative 13. Yes. Did I go too fast? No? Okay. Next one is negative 1. Negative 1 plus 12, positive. Negative 1 minus 6, negative. So that's a positive times a negative, which is a negative. What's the opposite of negative 1? A positive times a negative gives you a negative. You can ask, Anna? No? You don't want to ask? Okay. Yeah, Bernadette. Okay, so this was a negative 13 plus 12, which is a negative. This is negative 13 minus 6, which is a negative. A negative times a negative is a positive. The opposite of negative 13 is a positive. So that's a positive times a positive. Positive. Yeah, you're good. I do this mentally. If you need to write out and do all that, go for it, right? No problems. Okay, 1, positive 1. 1 plus 12, positive. 1 minus 6, negative. So a positive times a negative is a negative. What's the opposite of 1? Negative 1. So negative times a negative is a positive. And the last one is 7. Both of my factors will be positive, right? 7 plus 12 is positive. 7 minus 6 is positive. But what's the opposite of 7? Negative 7. So that's a negative. That's only one of them. So that's going to be negative. Okay? So this is asking for where is f of x decreasing? So I'm focused on where the sign of my derivative is negative, which is
6 to positive infinity.
So I heard negative 12 to 0. 6 to infinity. One more, then I'm done. Then it's your turn. So hopefully I'm going to give you 10 minutes. One more. David, question? Okay. Questions are great, right? Because the people that watch this in a couple years, they probably have the same question you do, right? Or listen to Eduardo. All right, number 4. Okay, number 4. What did they give us? What did they give us in number 4? The original. What do they want us to make a conclusion about? The derivative. So if I need to make a conclusion, if I need to make the conclusion about the derivative, where do I need to go? The second derivative. I need to go past it. So if they gave us the first derivative, the original, I need to do this twice. All right? I need to find the first derivative and then find the second derivative. I know. So I'm just showing all the iterations that are going to happen when you try this on your own. What's the derivative of negative x cubed?
Negative 3x squared.
Okay. Derivative of 12x squared.
24x.
And then this is minus 36. Again, don't stop here, right? Because I want to make statements about this. So I've got to go one past it to the second derivative. Okay, the derivative of negative 3x squared.
Negative 6x.
The derivative of 24x.
24.
24, right? This is actually a linear function now. All right, so linear functions are, they are never going to be undefined, so just set it equal to 0. Now you can factor this if you'd like. If you want to factor out a negative 6, you can. Most of my students will just solve this by moving the 24 over. And so what is our critical point?
Negative 4.
Positive 4. Positive 4. All right, so we can draw our number line. And we just care about 4.
This is so easy.
I know. So a lot of students, they're like, oh man, I got to do it twice. Yeah, you got to do more work up front with the derivatives. But usually, because what's happening to your degrees, they're decreasing. Usually the back end part is simpler or less, not maybe not simpler, less time. Okay, critical point between negative infinity, or should say, sorry, test point between negative infinity and 4. I'm going to use 3. And then on the other side, 5. So this is the sign of the second derivative to make conclusions about the first derivative. So this one is, since I didn't factor it, might be a little tougher to plug in. All right, but what's 3 times negative 6? Negative 18 plus 24 is a positive, right? It'd be positive 6. And then if I plug in 5, that would give me negative 30. Negative 30 plus 24 would give me negative 6. So this one's asking about where is the derivative increasing. So that would be where is the sign of your second derivative positive. So f prime of x is increasing on the interval negative infinity to 4. And that is it.